Selamat siang, Bapak Ibu semuanya. Ada Pak Toti ya? Masih beberapa menit ya, Bu ya?
Masih ya 10 menit. Nah, ini
Oke.
Profesor Ehab udah masuk. Good morning, Profesor Ehab.
Hello, good morning.
Good morning, Professor Rehab.
Good morning.
Yeah, good morning. Thank you for for your time to share your information, your expertise in this webinar. Thank you so much.
Thank you.
Nice to meet you in here.
Me too. Me too to be with you
Yeah, so we
in
will
this
start
important webinar.
yeah, we will start maybe in next 3 minutes. Yeah, but we are still waiting for other speaker. But it's okay. We can start from you maybe because you already join us. Yeah.
Okay.
Yeah. Just a minute. 3 minutes.
Amazing. Amazing.
Hi, Soher. How are you?
Good morning, Jenny. This
Good
is our
morning. Good
webinar
morning.
together. I
Yeah.
wish to
How are you?
find dear. Good morning, Dr. Ihab.
Good morning, Prof. How are you?
Fine, thank you. Thank
Hope
you
you
for
are doing
joining
well.
us.
Thank you. Thank you.
Professor Mohammed Taufik also already joined us. So maybe we can start, yeah?
Yes, okay.
Already on time. Well, okay.
And let my talk be at the end because we will benefit first with the role of they will explain more than me the impact of microplastic on the environment. Then I will make my speech at the end. Okay?
Okay. So you are the last one.
Yes.
Okay. Yeah, ladies and gentlemen, today is Thursday. Yeah, good morning. for our college speakers in there. And good afternoon to all of our participants, mostly from Indonesia participants, joining us from across the globe. Assalamualaikum warahmatullahi wabarakatuh. It is my great pleasure for us to welcome to today's seminar. We usually introduce seminar every Thursday, but 4 p.m. Indonesian time, because today is we are joined over the globe. So we adjusted the time into this 2 p.m. in Indonesian time. The theme of today's webinar is a very important one: breaking down microplastic solution for a cleaner future. So my name is Geni Rina Sunario. I'm honored to serve as your moderator for this critical and timely discussion. Allow me to briefly introduce myself. So I am from the International Council for Women Industry and Technology. And I am the responsible person in the Indonesia Nuclear Society as the woman development. And I also, as I mentioned before, so HIMNI has a program every Thursday. We conduct webinars, at 4 p.m. So development in the nuclear fields under HIMNI, where I work to bridge science, policy, and community engagement. Our journey in here is advocating for sustainability, innovation, and capacity building initiatives has led us to this webinar, which aims to address one of the most pressing global environmental challenges, microplastic pollution. This webinar is a collaborate effort between the ICVT and International Council for Women in Technology and Innovation, Women in Nuclear Tunisia, Women in Nuclear Africa, and also Indonesia Nuclear Society. Together we share a vision of fostering global dialogue and driving meaningful solution for sustainability and environmental protection. Through this partnership, we aim to create a platform that not only raises awareness, but also inspires action to address the growing issue of microplastic. We know that maybe our speaker will describe in detail about the microplastic that has a smaller, the size is smaller than 5 millimeters, maybe. I'm not an expert on that. And come from the breakdown of larger plastic or are intentionally manufactured for industrial purposes. They have infiltrated every part of the planet, from the depth of our ocean to the air we breathe, and also even into our own bodies. So let's we can hear the more detail from our expert today. So today we are honored to have distinguished panels of distinguished speakers, of course, for over the globe joining us. Professor Sohail Kora, so she's the president of the Women in Nuclear Africa. So good morning. And Professor Dr. Mohamed Taufik from Egypt, Professor Amira Zouak from Women in Nuclear Tunisia, Professor Ehab Mohamed, from Egypt, I think, and Dr. Nadine from Congo. So we are 5 speakers. We only have maybe 1 hour and 30 minutes, maybe. So I will let every speaker maybe around 15 minutes or more than that. Around 15 minutes to keep the time. So, professors, actually, I would like to ask Professor Sohail for opening these webinars, but she liked to be the last speaker in here. So we are having Professor Ehab, or maybe Professor Sohail, you will say something for opening webinar?
No, you said everything, and let's save time and let everybody speak. Okay?
Yeah. Thank you. So for the first one, I will offer the mic to Professor Ehab. So the time is yours now, Professor Ehab.
Okay. Okay. Thank you, Dini.
Yeah.
Good morning, everyone. Today, I'll introduce my presentation entitled Microplastic in the Environment, Challenges and Solution. The outline of my presentation is introduction, source of microplastics, distribution of microplastic, pathway, impact on marine human health, challenge in microplastic research, analytical techniques, legislation and policies, microplastic removal technique innovation, case study, microplastic in food chain, microplastic and climate change, public awareness, future research direction, a role of industry community initiative in education and advocacy innovation in detection. I start the introduction by questions. What are microplastic? Microplastic is small particles less than 5 millimeter in size, and it's divided to primary and secondary. Primary, like microbeads, secondary, like fragmented from larger plastic. Why are microplastics important? Pervasive in ecosystem and human environment, potential risks to organisms and human health. Where do microplastics come from? Microplastic end up the environment through many different sources like degradation, microbeads found in cosmetics, synthetic clothes. How do microplastic end up? There are many ways that microplastic enters the environment.
Sorry, Professor
Plastic
Ehab,
cannot-
do you want to share your PowerPoint?
Ah,
No?
So you will upload it. I sent it to you so that you will upload it. Because it's easier that you upload our talks.
Could you upload it from your Professor Sawyer?
Yeah. It's okay.
Okay. Okay.
Batman.
Okay. Screen share. Screen share.
And?
I think that.
Yeah.
Okay. I start again.
Mhm.
Okay. My presentation entitled Microplastic in the Environment, Challenges and Solution. The outline of my presentation, introduction, source of microplastic, distribution of microplastic pathway, impact on marine life, human health, challenges in microplastic analytical technique, legislation, microplastic removal, innovation, case studies, microplastic in the food chain, microplastic and climate change, public awareness, future research, role of industry, community initiative, education, advocacy, innovation in detection. I'll start my introduction by question. What are microplastic? Microplastic is small particles less than 5 millimeter in size, and it's divided to primary and secondary. Primary like microbeads, secondary like fragmented from larger plastic. Why are microplastic important? pervasive in ecosystems and the human environment, potential risks to organisms and human health. Next. Where do microplastic come from? Microplastic come from degradation of larger pieces of plastic, microbeads found in cosmetic, synthetic clothes. How do microplastic inside? Next, please. There are three main ways that microplastic enters the environment. Plastic in landfills, littering, products that go down the drain. Next, why are microplastic bad? That's important question. Because microplastic absorb and release toxic chemicals. Microplastic are also mistaken for food by organisms. When microplastic are ingested, they can cause a blockage in the gastrointestinal tract of organisms, tricking them into thinking they are fully living, then to starve to death. Next, what can we do to help and prevent this pollution? By individual action, reduce plastic use, industry level change, sustainable product design. Next. Three, government policies and regulations like ban harmful products, encourage recycling, monitor and research. Number four, education and awareness, public campaigns, school program, social media advocacy. Next, sources of microplastic. We have the source of microplastic primary source, like microbeads, industrial processed plastic pellets. Secondary source, like degradation of larger plastic, like bags, bottles, synthetic textile, tire abrasion on road. Next, please. Distribution of microplastic. Where are microplastic found? It is found ocean and freshwater, soil, agriculture, environment, atmosphere, and urban settings. The second global scale, found in remote regions like Arctic, and accumulation in food chain. Next, pathways of microplastic into the environment. Next, marine system, river discharge, ocean current, and rivers. Terrestrial system, agriculture application like sewage, sludge, and finally atmospheric pathway like airborne microplastic from urban areas. Next, please. Impact of on marine life. We have two categories in this factor. Physical harmful, negatively, physical harm and chemical toxicity. Physical harm like blockage of digestive system in marine organisms, chemical toxicity like leaching harmful, absorption of pollutant. I move to another factor. Impacts on terrestrial ecosystem. We have two categories, soil degradation, plant peace. Next, impact on human health. Entry points like consumption of contaminated food and water, inhalation of airborne microplastic. Health risks, inflammatory response, potential endocrine disruption. Next, please. Next. Challenges in microplastic. Detection, measurement, limitation of current analytical techniques, standardization, lack of consistent protocols, and finally, data gap, insufficient long-term studies. Next. Analytical techniques for microplastic. We have 3 techniques for microplastic. Visual inspection, like spectroscopy, spectroscopy, like IR and Raman, thermal analysis, like pyrolysis, GC, mass spectroscopy. Now I move to legislation and policies. International policies, we have United Nations Initiative on Marine Litter, regional efforts like EU ban on microplastic and microbeads, local action like community-driven cleanup. Next, microplastic removal technique. We have more than one technique for removal of microplastic. Number 1, filtration system, advanced wastewater treatment, bioremediation, microbial degradation, and innovative approach like magnetic absorption. Next, in this presentation, I have 7 case studies, but I mentioned just one case study due to the shortage of the time. The first case study in this presentation, microbeads ban success in the United States and Europe. Microbead commonly used in cosmetics and personal care were identified as a significant source of primary microplastic entering the aquatic system. What is action taken? The United States passed the Microbead from Water Act in 2015, banning this manufacture and sale of rinse of cosmetic containing microbeads. The European Union followed the same regulation, but after the USA in 2018. Next, please. Second case study is a Great Pacific garbage patch and microplastic. Next, please. Synthetic fiber pollution. Next, please. Synthetic fiber pollution from textile. Next, microplastic in Arctic. Next, community beach cleanup in India. Next, microplastic removal and wastewater treatment plants in Sweden. Next, biodegradable plastic in agriculture application. Now, next please. Now I move to microplastic in the food chain. Entry points into the food chain: aquatic system, freshwater system, terrestrial system, atmospheric deposition. Number 2, bioaccumulation and the biomagnification, like bioaccumulation, microplastic accumulate in the digestive system of organisms, often causing physical blockage or reduce feeding efficiency. Biomagnification, like predators, higher in the food chain, like larger fish, birds, and mammals. Number 3, commonly contaminated foods, like seafood, salt, water, honey, and sugar. Next, please. Implication for human health. Ingestion of microplastic, potential health risk like physical impacts, accumulation in the digestive tract, chemical impact, leaching of toxic additives like bisphenol, bisalate, etc. Inflammation and immunity response. Microplastic particles may trigger inflammation or oxidative stress. Next, please. Microplastic and climate change. This slide is very important. Microplastic contribute to climate change. How? Plastic production and the carbon emission. Plastic are derived from fossil fuel and zero production emit significant amount of greenhouse gases, including carbon dioxide and methane. It is estimated that a global plastic industry accounts for 3 to 4% of global GHG. Entry-intensive recycling process, degradation, and methane release. Next, please. Next, this figure shows the atmospheric microplastic source to the western United States of America, as we show. Next, please. Now I'll talk about public awareness campaigns. Objective of public awareness campaign. Educate the public, promote behavior change, mobilize communities, influence policies and industry, media outreach, educational program, collaboration, visual storytelling. Next. Future research direction. What about it? Detection and qualification of microplastic. We have seen standardization of methods, advancement in detection technology, automated analysis. Next. Community initiative. Clean up campaigns like beach and river cleanups, urban cleanups. Next. Innovation in detection. We have three categories. Number one, challenges in microplastic detection. Because of number one, small size, complex matrices, standardization. Two, advanced analytical techniques like spectroscopy-based methods, FTIR, Raman, pyrolysis, gas chromatography, mass spectrometry, fluorescence microscopy. Next, please. This final. I have the fun. Thank you so much. Thank you, Professor Sohair and the organizer, Dini. Thank you for the attendances. And the microphone will move to Dini. Dini.
Yeah, okay. Thank you so much, Professor Ihab, for your very clear presentation. And now, yeah, we can collect all this presentation first, and then question and answer will be at the end of this webinar. So for the second one, I would like to invite maybe Professor Mohammed Teha.
Muhammad Tawfiq.
Mohammed Taufik, sorry.
Good evening.
Good evening.
I'll start sharing my slides. Shall I start now? Can you hear me?
Yeah, it's okay. Perfect.
You can hear me well?
Yes.
Thank you very much. Okay, my lecture today will be the effect of microplastics on human health. First of all, I would like to thank my professor, dear Dr. Professor Sohail Korar, for inviting me to this lecture. She's always a pioneer in the field of environmental health and research. I'd like to talk today about, my name is Mohammed Said Tawfiq. I'm a professor of internal medicine, endocrinology and diabetes at the Egyptian Atomic Energy Authority. Today I'm talking about the effect of microplastics on health. What are microplastics? They are small pieces of plastic less than 0.2 inches in length that occur in the environment as a consequence of plastic pollution. They are found in a variety of products that we use every day, such as cosmetics, our clothing, plastic bags, bottles. They readily enter the environment in wastes. There are different shapes of microplastics, such as spheres, fragments, and fibers. Most of them, except with the intentionally manufactured micro beads or fibers, arise from the deterioration of larger plastics. So microplastics come out of macroplastics. The medically important microplastics are made of polystyrene, polyethylene, polypropylene, or polyvinyl chloride. I'd like to divide them into microplastics and nanoplastics. Microplastics are residues with a size of less than 5 millimeters, and nanoplastics are plastic residues with a size of less than 1 micrometer, nano size. Examples of microplastics, I'd like to divide them into primary microplastics, which enter the environment directly in the same size as they were delivered. They might be airborne, waterborne, or they may be found in the soil. They include microbeads found in personal care products and plastic pellets used in the industrial manufacturing, and synthetic plastic fibers which are used in textiles. Secondary microplastics, on the other hand, arise from the breakdown of larger plastics. It typically happens when larger plastics are exposed to the weather conditions, such as waves, wind, and ultraviolet radiation. What's the effect of microplastics on the cell? We'll start with the cell membrane. There is an interaction. Since microplastics are very small in size, they are readily absorbed by the cell membrane and can cause disruption or pore formation or thickening. There's an alteration in the membrane. A recent study found that cell lipid membranes are easily affected by microplastics. The cell membrane bilayer becomes lower in density. Its fluidity is increased. There is membrane thickening. Polyethylene aggregates can cause pores in the cell membrane and serious damage to the cell membrane bilayer. If we go to the mitochondria, the membrane of the mitochondria is affected in the same way as the cell membrane. The mitochondria is a powerhouse of the cell. If this membrane is broken, you find first of all swelling of the mitochondria, affection of the mitochondria cristae, where the oxidative phosphorylation processes occur and the formation of ATP happens. This does not happen properly in the cell, so the powerhouse is lost. So this is the effect of it on the mitochondria: swelling, disruption of the mitochondria, and loss of its function. This can lead to cell derangement and death. Also, on the nucleus, the microplastics can affect the nuclear membrane after being oxidized by ultraviolet radiation or weather conditions. When the cell membrane bilayer is disrupted, it arrives to the cell nucleus. Then the cell nucleus is affected by these microplastics in the form of nuclear swelling, disruption. The DNA of the nucleus is also affected, which could lead to mutations and the increased risk of development of tumors. So this is what happens in the nucleus. We can see here ultraviolet exposure leads to oxidation of these microplastics, and then the nucleus is affected by these microplastics, and the mitochondria. We can see the mitochondria is affected by the reactive oxygen species produced by the microplastics, and the nucleus membrane is disrupted also, thus affecting the DNA, and mutations may occur. Okay, what about the different organs around the body? Are they affected by microplastics? Yes. For example, let's start with the respiratory system. Airborne sources of microplastics are textiles. When we fold our clothes, microplastics can be produced. Cigarette smoking contains microplastics. The smoke of cigarettes contain microplastics. Self-care products contain microplastics, such as aerosols. Outdoor sources, being exposed to the car tire fumes or industrial plastic waste, can also expose our lungs to microplastics. We have here a diagram of us inhaling microplastics, whether indoor or outdoor sources. Microplastics have been found in lung tissue, in surgically resected lung tissue samples. They've been found in human lung tissue autobiopsies. They've been found in bronchoalveolar vag samples. So they are found in lung tissue, even when resected. You find it in lung tissue when resected, and we know that the lungs are exposed to microplastics. How does this happen in the lung? The reactive oxygen species lead to oxidative stress and damage. The alveolar cell membrane is lost, as we talked about cell membranes before. There is alteration in alveolar cell morphology. Mitochondria is damaged. There is genotoxicity and DNA damage, which could lead to lung cancer. There's reduced cell division and proliferation, leading to alveolar cell damage, which could result in lung fibrosis and loss of function. We can talk now about microplastics and gastrointestinal health. Microplastics are ingested in the gastrointestinal system through different ways, through water, drinking water, contaminated with microplastics, heating water in plastic utensils or cups, heating food in plastic containers. These microplastics and nanoplastics seep into the food and drink. They act as carriers of toxins, such as heavy metals, microbes, from the environment into the digestive system. How do they cause injury? Through reactive oxygen species, such as superoxide dismutase, and catalase, and singlet oxygen. Microplastic exposure can cause the stimulation of various cytokines and such as interleukins, tumor necrosis factor, interleukin 1b, which also cause inflammation of the cells, damage to the cells, swelling to the cells, and dysfunction of the cells. Microplastics can also carry injurious bacteria such as the Helicobacter pylori. We can see a pandemic of Helicobacter pylori. And microplastics readily serve this Helicobacter pylori to the stomach through the ingestion of contaminated food with both the microbe and the microplastics. The microplastics affect the gut natural bacterial flora, the gut microbiome, what we call. And it changes the good microbacteria, good bacteria, into unhealthy microbiota. The unhealthy microbiota increase the permeability of the intestine and cause the intestine to be permeable to the microplastics and they're seeping into the general circulation. We have a diagram. The protective microbiota is changed to harmful microbiota when exposed to microplastics. Okay. There is histological alterations in the gut. The cells of the small intestine, for example, become vacuolated. The nuclei become small. Nuclei could rupture. And a process of apoptosis or cell necrosis in the gut could occur, together with increased permeability of the intestine and the loss of the intestinal barrier to these microplastics, which could lead them to enter the circulation. Here is a electron micrograph of microplastics being colonized by microbiota. They can affect the health through various ways. We are smoking, use of personal hygiene products, aerosols, creams, which are not natural or all chemicals, contain microplastics. And by direct contact, they can affect the skin, causing inflammation, swelling of the skin, redness of the skin. Even the barrier, the cutaneous barrier of the skin could be lost by these microplastics, especially that the nanoplastics are very small and can enter the skin easily. A study by Han in 2024 found that microplastics can cause skin aging through the loss of mitochondrial DNA into the cytoplasm. So this was a very interesting study. The loss of mitochondrial DNA and its seeping into the cytoplasm led to inflammatory process, which led to skin aging. So this is very important. We can see it in this diagram. Mitochondrial DNA is lost and it causes inflammation and aging of the skin. In the cardiovascular system is another system affected by microplastics. Either the blood vessels and the intima and endothelium of the blood vessels is affected. The heart rate might be affected by microplastics through affection of the cardiac pacemaker. The cardiomyocytes, or the heart cells, muscle cells, the cardiomyocytes, could be affected by these microplastics, leading to damage, loss of function of either the intima of the blood vessel or the heart muscle. This occurs through two pathways: reactive oxygen species, as we said before, and the cascade of the cytokines through interleukin 6, interleukin 1b. There is altered cardiomyocyte electrophysiology, altered cardiomyocyte function, and the cardiomyocytes could be damaged and fibrotic with ensuing heart failure. We have here a diagram of the effect of microplastics on the blood vessels. It affects the endothelium, the intima of the blood vessel. It could allow for atherosclerosis to occur through depositions of lipids. Also, the myocytes may be affected by fibrosis and loss of function. The rest of the effects of microplastics are usually found in experimental animals, but they could affect the humans as well. The central nervous system could be affected by nanoparticles. A study by Liu et al. In 2022 found that microplastics affect the cognitive functions of rats or mice and led to anxious and depressive behaviors in these animals. This could also, we could compare this to humans. This could also occur in humans. It could affect the cognitive function and lead to mood swings in the humans. If it happens in the experimental animal, it can happen in humans. Okay, I'm almost finished. The microplastics and the reproductive system, fertility effects in adult males have been studied in experimental animals. Oxidative stress and cytokines could reduce the size of the testis and affect the fertility of adult males. And it crosses the blood-testis barrier. These microplastics can cross the blood-testis barrier and affect the testis. Also, they are found in prostate, in human tissues, in prostate tissues. People who patients who underwent transurethral prostate resection, their prostates were analyzed, and they found that they found plastic particles in the prostate. So it could, microplastics can enter anywhere in the body. It affects the fertility in adult females. We found that the ovaries of these experimental animals had reduced weights and demonstrated altered dynamics of the follicles. The mature follicles were reduced and the growing follicles were reduced and more replaced by atretic and cystic follicles. Also, the hormones were affected, such as the production of estrogen, anti-Mullerian hormone, were reduced, and increased concentrations happened of luteinizing hormone and follicle-stimulating hormone, which shows the dysfunction of the ovaries. They found that microplastics in female placentas in experimental animals. The placentas were reduced in size in some experimental animals, and this led to an effect on the fetus. Since the placentas were smaller, the fetuses were reduced in weight, and maybe abortion occurred. The microplastics and nanoplastics were between 100 nanometers to 10 micrometers. Microplastics have been found in breast milk. A recent study in 2024 found microplastics in 39% of breast milk samples, which shows that the microplastics can reach any organ in the body and have a significant effect. These particles were polypropylene, polyethylene, and polyvinyl chloride. In the liver, experimental animals showed affection of the liver, such as vacuolation, swelling, loss of function, and increased enzymes such as catalase, glutathione transferase, and alkaline phosphatase were increased, denoting damage of the liver cells. Here we are. The microplastics were studied in the liver of fish, mice, and birds. And we found increased cytokines in their serum, increased damage to the liver, changes in cell morphology, maybe fatty liver in some animal samples. Okay. The kidney was the same. Damage to the kidney in experimental animals occurred due to microplastics. It induced apoptosis, and in another study, microplastics were found in the rat cadavers between 50 and 20 micrometers. So microplastics affect many organs: the liver, the kidney, the heart, bone, brain, ovary, testis, embryo, prostate. Wherever the microplastics go, oxidized microplastics can cause damage. My medical recommendations are reduction of the use of plastics near water and food by finding alternatives to plastic bags, plastic cups, bottles, and food containers. Using air and water filters to efficiently reduce exposure to microplastics and nanoplastics, whether by breathing or ingestion. Avoiding the use of chemical cosmetics and personal hygiene products such as sprays, and try to use alternative natural products instead. So the more we can stay away from plastics, the more our health is better. And I would like to thank the organizing committee and thank you all.
Thank you so
very
much. Yeah, thank you so much for your very interesting presentation, Professor Taufik. And then, do you mind to share your PowerPoint to us? Because there is participants is really wanted.
Okay, shall I share it again?
Yeah.
Okay.
I mean that the electronic file of your presentation.
After the presentation, I will share it with Dr. Suhair, and she will give it to the committee.
Okay, thank you so much,
Yes.
Professor Mohammed Taufik.
You
Yes.
can send it to me and I will resend to you. Okay.
Okay.
He's always cooperative, Dr. Mohammed.
Thank you so much, Professor Mohammed Taufik. And then Professor Sohair, I couldn't see Nadine, Dr. Nadine, and then Amira. There is not yet joined with us.
Dr. Nadine has sent you a video because she was afraid that she cannot be in contact.
A video?
The last thing I sent, she had a video. She sent you a video. The last thing I sent you because she will speak about the ocean, and actually they first discovered the microplastic when they found it accumulating in oceans. Not discovered, they just took care of the problem when plastic was when the oceans were polluted with plastic.
Yeah, it will be very interesting one. I couldn't find the video. Do you send into email or
WhatsApp? I sent by both. I will resend to you. It is called South Atlantic Congolese. South Atlantic Congolese Zoo.
Okay, I can. Yeah, I'm waiting for your sending.
Okay, you can upload mine. I don't see Amira, Dr. Amira.
Amira, okay. So maybe now is your turning, Professor Sohail.
Ya tergantung, ya tergantung kan kita ada.
Professor Sohail. So it's your turn.
Yes.
Yes.
Okay, I can speak now.
Sisipan
Kindly
160
upload
kan?
because
Oh, do you want me up?
yes, upload mine. I don't know how to upload it, but I will learn.
Okay.
Kan ada statistik ya. Yang aku statistik lu nya balik dari skill. Boleh kan? 82, nomor 88.
Kan tadi nggak PS tak? Belajar dong.
Oke, sama.
Kita ada
Yes.
Good afternoon, everybody. I am happy today
Tadi
with this first
Kayak workshop training ya sama di Bapura kan.
cooperation with Professor Jenny. My speak today will be the role of NGOs in microplastic pollution as an example of collaboration with the government. Next, please. JD, next. As we know, the government main task is to provide major projects, and their actions are often influenced by priority, resource constraints, and insufficiency. Many government cannot do anything. So this comes the role of NGOs, which are non-profit organizations, to help in the solving the problems as they have more contact with the communities. And they can make projects which are not prioritized by the government. So my talk will be on the project we carried out for microplastic. Next, please. As you know, in Egypt runs the river Nile, which comes from Central Africa, and actually we found it polluted. So as NGOs, we work in environmental protection, sustainability, human rights, women empowerment, world peace. We fight poverty. We make health campaign. We improve the skills and capacity of the youth to have better jobs, and we provide mother-child care, and we fight illiteracy. Next, please. So one of the next. What is we as NGOs, we have to address the problem of plastic solution. We did it by we can recycle, we can reuse, and we can reduce. So our strategy was to reduce the plastic in the environment, or the plastic in the river Nile. We started a project called the Sobek. Sobek is an ancient god, and he's looked upon as the guardian of the Nile. It represented a crocodile or a man with a crocodile head, and it is looked upon as the creator of the Nile. And occasionally harsh character. So this Sobek, excuse me, next. You have someone to translate? Next, Jeannie.
Next. This picture.
Yes, so we started a project. We had school children, we had youth, and we made a trip through the River Nile to a construction along the River Nile called the Qanatar al-Khairiyya. It is like a small dam. It's not a big dam, but a small dam built to control the flow of water from the south to the west, to decrease the amount of water that falls into the river, into the sea. You see, the Nile comes from Central Africa, and its end is in the Mediterranean Sea. So we had youth, we had school children. Excuse me, please. Next, please. Next, Jeannie.
Yeah, it's done. Maybe takes time to. The photo.
These are school children, and we had youth from the university. These are youth from the university. Next, please. And then we went to the Qanatar al-Khairiyya. You will see now it's construction along the River Nile. Next, please. This is the construction along the River Nile, and you can see at this part of the at the lower part of the picture, plastic waste. And these children, we got into boats and we went to this construction and we gathered the plastic which is accumulating at this structure. At the end of the day, these children or these and school boys and girls give certificates because they participated in cleaning up the River Nile. And of course, they will go to their school mates and will tell them about their experience. And this will create an interaction to encourage the youth to come again and share in cleaning up the River Nile and in disseminating the idea of microplastic among the population. Next, please. Next, Jeannie.
It's done.
This is an island in the River Nile. It is called the Corsaya Island. And in this Corsaya Island, it is inhabited by fishermen and farmers. And in this Corsaya, we have established a building for the recycling of the plastic we gathered from the River Nile. Actually, at the beginning, each fisherman who brought a big amount of plastic was given money. By the time they became aware of the problem and they were happy to work with it. Next, please. Next, Jeannie.
Yeah.
So you can see this building over there. And we have, in order to go to this island, we cross it by means of boat. And there we will see how we were able to make small projects for inhabitants of this island and improve the women's status who are working in this project. Next, please. So we will gather the plastic. The plastic would be made, cleaned up and made into beads, and by means of solvents, we will create a sort of dough, and from this dough, we will make threads, and women were taught how to make a good handcraft from this plastic. Next, please. Next. So these are some of the handcraft created by the women, and they can sell it and gain money from this. And this we increase, we fight poverty, and we make women empowerment. Because this is a small project, but they can earn from it money. You can see that they can make boxes, baskets, and baby for the baby when he eats, not to spill on his clothes. Next, please. Next. Actually, this project was between Egyptian Rotary clubs. In Egypt, we have around 100 Egyptian Rotary Club, and the Ministry of Environmental Affairs and businessmen. When we went to the River Nile, businessmen will provide us with the boat, and businessmen will provide us with the life jackets, which the children wear in order to gather the plastic from the River Nile. Also, we gathered money, and we were able to create a ship made just for cleaning up the River Nile from the plastic. And we can see, as we can see, that in between there is a mesh to help gather the plastic waste from the River Nile. Next, please. Next. This you can see this the mesh, and this is made special for the clean up of the River Nile.
Where are you disappear? Well, okay, ladies and gentlemen, we are waiting for Soher to join with us again. So in the meantime, I will deliver a question and answer. Maybe Professor Ehab and Professor Tovik still in here? Hello?
The internet was cut off. It means there was a problem with the connection with Egypt in general.
Okay, okay. I will. Yes, you can continue. Soher.
Okay.
Yeah.
Also, we made a sort of health campaign to this island, and there we gathered the children, and we gave them lecture about the importance of keeping the Nile clean, and we provided help. Actually, we were funded by Etisalat, which is a mobile company in Egypt, and drug companies provided us with drugs and equipments and for help. They provided us with bed to construct a health campaign for this island, Corsaya Island, in which is situated the project for microplastic recycling. It is a small project, but it helps. Next, please.
Yeah.
And thank you. This is me cleaning up the River Nile.
So thank you so much, Sohail. There is no Amira still in here. Amira is not joining us. So let us continue with the question. I hope that all the speakers will be ready for the questions. Hello. And then for the first question coming from the chat, I could find, this is from Nilawati, Ibu Nilawati. Ibu Nilawati mau berbicara langsung atau saya terjemahkan? Oke. This is for maybe for Professor Ihab.
Diterjemahkan aja.
Yeah, for Professor Ihab. There is a question from Mrs. Nilawati. She asks about the methodology. She asks about how to analyze the microplastic from the salt sample. And then, is there any analytical microplastic methodology to find that can be implemented to analyze it? And then, how is the second question is bagaimana mengarah? And the second question is how the mechanism or to analyze the microplastic, the absorption of microplastic by the microalga. Maybe I don't know who will answer this one. Maybe Professor Ihab or Professor Mohammed or Professor Sohail.
Well, as far as I know, I'm not working with, but you see in South Africa, and in Namibia coast, there are the animals that live on the plankton beneath the water in the sea. And these were destroyed by pollution, and accordingly, the animals there living have disintegrated and found dead on the seashore. I cannot it's the bird that live in the south on it's I don't know, I cannot remember its name. I know it in Arabic. The bird which is black and white in front and lives in ice places. Disintegrated because of microplastic pollution and the plankton living there, and it is its food, so it's disintegrated.
Professor Taufik, do you want to add up another perspective answer?
I can't.
Still
We have Dr. Muhammad Said Tawfiq if you want. We have Dr. Muhammad Said if you have questions for him.
The microphone is still mute. Could you unmute your microphone, Professor Muhammad Taufik?
Yes, sure.
Yes.
Do you have any questions in the field of
Yes,
microplastics?
Dr. Muhammad.
Yeah, maybe you can add some answer about from the Ibu Nilawati. She's asking about the methodology, how to analyze the microplastic in the salt sample. Salt sample. Is there any methodology to find it?
The question for Dr. Ihab, because he was dealing with the soil and the winds and the That's Dr. Ihab. I was dealing with effect of microplastics on health, on
Oh,
different organs in the
okay.
body.
Yeah. Dr. Ihab, do you still hear? Maybe you can help us to answer the question.
No. I would like to say something that nowadays it is difficult to make a precise standardization of microplastic in tissue samples. And that's why the International Atomic Energy Agency is making projects in order to find a valuable method or reliable method in order to evaluate microplastic in different samples. So
Yes,
it is a project working on now, and it is not yet established.
yes. In my lecture, I recall I said that we could measure microplastics in tissues using a method called Raman spectroscopy, which is a method which can detect the concentration, the size, and the types of microplastics present in various tissue samples. So that was a method used and mentioned in the lecture. I will send my lecture to you, and you will find that method of detection of microplastics, but it's still under research. It is still under research, and
Okay.
various methods are postulated to detect microplastics in the tissues, human tissues, animal tissues.
Okay, thank you. Professor Muhammad Taufik, there is a question from Amita. Yeah, from Amita. She's asking about how can we expel the microplastic from our body? So instead of mitigate the microplastic in our body, how to expel?
Release it out. Well, the best way, we always say in medicine, the best way to cure is to prevent. So if we prevent, the more the body has its way of healing. If we abstain from microplastics through excretion in the stools, in the urine, through sweating, we can get rid of large amounts of microplastics over the days and weeks. If we expose ourselves to a healthy environment, the microplastics levels could be reduced if they are not very high to start with, if they weren't absorbed in high quantities. Following a healthy diet, sports, sleeping well, will all improve the tissue vitality, and we will, by time we get rid of the microplastics. Some things are deposited we can't get rid of, but most of the things circulating or in our sweat or in our breath could be got rid of by time, by healing and by eating healthy food and exercising, dieting like this. Drinking lots of water, plenty, lots of water could help get rid of microplastics that have entered recently. Microplastics that have deposited in the tissues are very difficult to get rid of.
So you mean that the microplastic can induce also the cancer?
By the way, it's dose dependent. If it's in small quantities, inflammation is induced or damage to the organs, slight damage, severe damage. If it reaches the nucleus in large quantities, and especially the smaller the size of a microplastic, this could induce DNA damage because the nanoparticles, which are oxidized, the nanoplastics can reach the nucleus and can damage the DNA, causing mutations. So it's dose dependent and size dependent. So
And
it can cause cancer sometimes, in some instances, if it's a large amounts and smaller particles.
Very interesting. There is a question also from the Ernie Sukocho. She's asking about how significant is the role of microplastics in disrupting the ecosystems and human health compared to other pollutants like heavy metals. So which one is more dangerous?
No, I think heavy metals is more dangerous than in the field of health. Heavy metals is more dangerous, but plus microplastics can carry heavy metals. So microplastics is a problem because it can carry these heavy metals into the body. So they can act as a vehicle. If it's not causing the severe damage caused by the heavy metals are more injurious, but microplastics and nanoplastics could carry these heavy metals into the gut system and into the respiratory system. So it is dangerous in a way as a vehicle, as a carrier.
So the effect is different between the heavy metal and the microplastic to our body. You mean
Yes.
like that?
Yes,
Yes.
it can carry microbes as well. You know, in the corona pandemic, we found that microplastics were carried those viruses. They can carry viruses. They can carry the gut Helicobacter pylori, which causes acidity, and carry heavy metals, and it can carry carcinogenic smoke particles in the air. So they act as carriers, whether it's airborne or ingested or by water, and they are dangerous. Of course, they are very significant. They were long forgotten, but now there is more concentration on microplastics and their effects. They are either directly injurious or they can carry injurious particles like microbes and heavy metals and so on.
And then the continuing question coming from the Amita also. She's asking about can we separate the microplastic from the environment? And Professor Soher already described about how to collect the plastic itself. And
yes, I mentioned, Dr. Soher mentioned it in her lecture very clearly. She goes on trips to remove microplastics from the river stream. Okay. I talked about water filters at the level of the household. Water filters and air filters could help reduce our exposure to microplastics. And taking care of our food and not
Well,
using.
what I can say that microplastic people did not get aware of microplastic problem only in recent years, and it is a new field of study which needs a lot of experimentation and need of lots of work in order to make it more clear.
Okay. Najwa, I can see you, Najwa. Do you have any question to the speaker, Najwa, Professor Najwa? Please, your mic is still mute. Unmute your mic.
Yes, my mic is working. Is this question for me about airborne particles? How can they be separated? Yes, there are stations around the world for the separation of injurious particles. There are scientific stations which can capture these microplastics and analyze them maybe by Raman spectroscopy. These are through filters in the air filters, water filters. They can get these microplastics and study them, whether it's water pollution or air pollution. Airborne particles could be captured by these filters and then obtained and analyzed by various methods, such as the Raman spectroscopy method of detection of microplastics. Airborne
Professor Muhammad Taufik, there is a very common question from our community in here.
Yes.
She's asking about how to avoid the food that is contain the microplastic.
We are all the time exposing ourselves to drinks and foods with microplastics in them. Many people plastic containers to heat their food. And we drink in plastic. Some people drink in plastic cups, the hot drinks. So these microplastics are formed from the macroplastics. Macroplastics are changed into microplastics and nanoplastics when we heat the food or when we drink the food in plastic cups or plastic. So avoiding these plastic containers could help us a lot. Avoiding forks and spoons that are plastic, for example, could avoid us ingesting microplastics. Many people use knives, forks, spoons, which are plastic, made of plastic, or cups, or utensils, or containers for heating of food in the microwave. The polystyrene, for example, polyethylene. All of these plastics easily degrade into microplastics, and they enter our food chains and our water supplies. So the best way of prevention is to avoid this, and especially skincare products also contain the chemicals contain microplastics that could cause skin inflammation and skin aging. That's why many people who use chemicals for chemical makeups or like that are affected by skin aging, as I mentioned in the lecture. I will share with you, as I promised, the lecture, and you will see all these points mentioned. The way of detecting microplastics, the way of avoiding the problems of microplastics, whether in food, drink, or air.
There's in your country, there is a very strong regulation about the microplastic.
Yes, I would like to ask Dr. Suhair Khura about these regulations because she's more aware of the regulation.
Professor Soher,
My
how is
professor,
the regulation in your country about the
I don't know the
microplastic?
regulation. Yes.
Well, I don't. What I can see in my country, that the Ministry of Environmental Affairs it has been involved in many projects for the cleanup of the River Nile, which provides water for us. And the project I have showed you is under the auspices of the Minister of Environmental Affairs in Egypt. And now we are trying to use paper bags in our groceries and things like that in order to reduce plastic waste. But I don't think we have laws.
But the activity that you have implemented, yeah, to gathering the plastic, is this related with the government regulation or just initiative from the NGO itself? Hello.
I think many supermarkets in Egypt now use paper bags and and cardboard cups. We've started to be aware of the danger of microplastics before the legislation has been delivered. The use of now paper bags and paper cups. Although the customers aren't happy with that, but they prefer the plastic bags because they are stronger. But it's happening. It's happening. Still, the plastic spoons haven't disappeared and forks, but the bags and the containers, people are using other materials other than plastic as food containers and bags to carry clothes. People are trying to, many textile companies are trying to reduce the percentage of plastics in the textiles, for example, and the fabrics.
Yeah, Professor Muhammad, your presentation is very interesting one. I want to ask you about the you already describe about the effect of microplastic in the radiovascular or something like that. Is there any evidence to suggest that inhaling airborne microplastic contribute to the respiratory or cardiovascular disease?
Yes, many studies have many studies have found in resected lung tissue when they carry out surgical operations and they remove tumors, they found in the tumor tissue microplastics. When they do bronchial lavage, which is washing of the bronchi, they find these small microplastics inside the lavage. Also, cardiac tissue samples, blood samples, plastics have been found. Blood clots in strokes, for example, they find these microplastics. Cardiac samples in cadavers. When they take biopsies from the heart of these cadavers, they find microplastics. So therefore, if you find the disease and you find microplastics in the samples, so this shows a causal evidence, a kind of causal evidence, as well as cell studies. For example, on cultured cells, we find that the microplastics affect the cell membrane, the nucleus, the mitochondria. So it would affect any tissue in general, lung tissue, gut, intestinal tissue. Okay. The most important three, in my opinion, are the gastrointestinal tract, the respiratory tract, and the skin, because these are the ports to our body. And then the other organs And the other organs are affected by these three organs. Because the doors are open. If I open the door through the lung or through the gut or through the skin, therefore I've allowed microplastics to enter my body. These are the first barriers and defense walls to these microplastics. They affect any tissue, lung tissue, respiratory tissue, gut tissue, skin, heart, blood vessels, reproductive organs. All of these are affected because the doors have been opened by these microplastics. They get oxidized. The oxidized microplastics, especially when very small, can enter easily the cell wall, and then the cell membrane, the cell nucleus, the mitochondria, and then affect any cell in the body. Especially through if it's airborne, through the nose, mouth, and the lungs. If it's ingested through water and food in the gastrointestinal tract, because the intestine is open, becomes open to these microplastics. By the damage occurring to the intestinal wall, it opens the door for the microplastics to enter the circulation. And also the skin, although the skin is a very strong barrier, it can allow some microplastics to enter. And very low dose, like the creams used and the sprays used. The aerosol creams. But you see, so
yeah, it's very we have to take caution. And how are the microplastic implicated in triggering inflammatory response or oxidative stress in human cells?
yes, there are two pathways for the microplastics to be injurious. We find these microplastics are readily oxidized by what? By the ultraviolet rays, for example. They react with oxygen and they become oxidized. When they become oxidized, they enhance two pathways. Our body feels oxidized particles when such as oxidized cholesterol, oxidized microplastics. And you find that inflammatory mediators in response to these microplastics are enhanced, such as interleukin-1, interleukin-6, tumor necrosis factor. All of these factors are increased due to the exposure of the cells to these oxidized, I want to say oxidized microplastics. Also, the oxidized microplastics, like any pathogen, enhance reactive oxygen species. Reactive species are stimulated by injurious stimuli, such as pathogenic bacteria. Oxidized cholesterol, for example, causes atherosclerosis. Oxidized microplastics can excite the oxygen species and therefore cause damage. If they are more than the defense system, the body has a defense system against reactive oxygen species that defend it, like such as vitamin E, vitamin C. These vitamins protect the body against oxygen stress. If the microplastics overcome this by an increased dose of microplastics, smaller size, the smaller the size, it's more injurious. The larger the concentration, it's more injurious because you have more particles, small in size, which are oxidized. So they act like bullets. It's like a bullet. A small oxidized microplastic acts like a bullet, entering the cell membrane, entering the gut, entering the respiratory system. You can imagine it like a bullet entering and breaking the integrity of the cell membrane, the integrity of the nuclear membrane, the integrity of the mitochondria, causing mitochondrial swelling, disruption. The cell disintegrates or enters a process of programmed cell death called apoptosis when exposed to these microplastics. So it's two pathways, reactive oxygen species and interleukins, cytotoxins. Cytotoxins, you see? Both of us together to destroy the cell membrane, to destroy the nucleus, cause mutation in the DNA. Once the microplastics reacts with the nuclear membrane, or it's in the cytoplasm, it can cause mutation through various intracellular mechanisms and pathways.
Yeah, so we have to take care of the microplastic. And how significant is the risk of microplastic exposure from drinking water? We know that water is everywhere in the bottle, particularly
Yes,
water. Yes.
I want to talk about this. This is very important. When we heat water in a plastic container or a plastic bottle,
Uh-huh.
freeze it and then reheat or thawing, and all this allows the microplastics to enter the water.
Mm.
The plastic bottles should be used once only, and I don't prefer plastic bottles. We should return to glass bottles, but that wouldn't be practical. But I think that would be healthier. But because when you put it in the refrigerator and remove it and heat, the different temperatures excite the macromolecules to become smaller molecules. The big plastic molecules become smaller and smaller, and the smaller they are, so that's in the water. It happens. So you can,
Mm.
if you have the ability to use glass bottles, or use the bottle once and don't freeze or heat it. You see,
Mhm.
if I drink from a plastic bottle, for example, I drink it from the box once only. I don't put it in the refrigerator or I don't heat it. If you
Ah.
keep or for example in the sun, this will release the microplastic. This is the most dangerous thing. If you keep your bottle of water in the car and close the car, and then the sun reacts with the bottle and the water inside, and the microplastics seep into the water and it's drunk. So that's very
Mm.
dangerous. Also, heating food in the plastic containers in the microwaves, the same idea.
Yeah, yeah. And then maybe this is the last question for you, Professor Mohammed.
Yes.
Maybe in your research, I don't know, you are the professor that you are having so many information about the recent status of the microplastic research. Is there any specific population, such as children or pregnant women, that are more vulnerable to microplastic exposure?
Yes, that's a very good question. Of course, children and pregnant females are more vulnerable to microplastics. Their immune system is affected. You find people who have chronic diseases also, like diabetes, hypertension, um, chronic liver disease, chronic kidney disease. Already the tissue is not viable as the normal tissue. The kidney, like many tissues I mentioned, the kidney, the lungs, the liver, when they're exposed to this extra stimulus, already a patient is vulnerable, for example, who has diabetes or hypertension. He's vulnerable to oxidized, for example, cholesterol entering the blood vessels. If children are yet developing their tissues, so they are more vulnerable to microplastics. So it's an additional injurious stimulus. And it's also it's a cumulative effect, and it's a dose-dependent effect and a size effect also. And so these tissues are not as viable or healthy as the normal person. So of course, when the damage will not take a long time. Okay, I'm afraid for pregnant women that the fetuses could be affected by microplastics because they enter the placenta and they can cross the placental barrier. And aging populations also have the same problem. Their tissues are not as viable, so they are affected more. I'd like to give an example. Females are more affected by cigarette smoking than males because they have smaller lungs. So I always advise a woman not to smoke because her lungs is smaller in size, and and this could affect her more. You see, so pregnant females also, their children are more susceptible to microplastics. The baby is still developing, so the baby, of course, for example, the fetus is more vulnerable to microplastics, naturally speaking, because it's added to the other injurious stimuli that affect people, the smoke pollution, hydrocarbons. You find microplastics entering into this problem and causing more problems. So it's an added effect,
Yeah,
especially
yeah.
aging people, pregnant females, children who are still developing.
Yeah, Professor Mohammed Taufiq, thank you so much for your explanation. Actually, we want to continue our discussion, but the time is we already 1 hour and 30 minutes. So I think that we have to close this webinar. So before closing this webinar, I want to ask each speaker to have a closing remark, to deliver a closing remark. Maybe started from the Professor Sohair, Professor Mohammed Taufiq, and then Professor Ihab.
Well,
Please,
I thank
closing
you.
remarks.
Okay, I thank you, Jenny, for organizing this webinar, and I thank my Egyptian speakers, Dr. Mohammed and Dr. Ihab, for participating in this webinar and providing us with, for me, it was a new knowledge in every aspect. And I would like that we cooperate together in the future, Jenny. I
Yes.
just want to add something. I said something about the bird in South Africa. It is Namibia. It is the penguins. Penguins are disintegrating in this area because they feed on plankton, and these plankton are due to climate change and due to plastic waste in these oceans have been disintegrating, and the penguins are dying because they cannot find its food. Thank you once more for the attendee, and thank you.
Thank you so much, Professor Zahir. So, Professor Muhammad Taufik, your closing remark, please. Your microphone. Yeah.
I would like to
Sorry.
thank Jenny and the organizing committee. I'd like to thank my professor, Dr. Siakura. And thank you for the questions. They helped me explain my lecture very well. So thank you very much. I was happy with the questions, and the questions were very to the point, and they helped me demonstrate the severity of the problem of microplastics. So I look forward to meeting you in other lectures, and thank you very much.
Yeah. Thank you very much for the speakers. I would like also to express my heartfelt appreciation to the International Council, Win Tunisia. There is a Najwa in here, Win Africa, and also participants coming from the HIMNI for their collaboration in the organizing this webinar. Very impactful webinar. Partnership like this remind us that global challenge require collective effort and shared responsibility. To all our participants, thank you so much for today's very impactful webinar. So we have to take caution with the microplastic or the water bottle or something like that. Thank you so much. Wassalamualaikum warahmatullahi wabarakatuh. And see you again next week with the different tema. Thank you so much. Stay healthy.
Terima kasih Bapak Ibu sekalian. Kita ketemu lagi Kamis depan dengan topik
Terima
yang
kasih,
sama
Prof.
menarik. Kami sambung.
Thank you, Jenny.